So guys, today I want to be go for explain a project. It could be related to classification problem. So we try to be go for understand the problem statement over here. Okay, this is the classification of galaxies, stars, and okay, stars based on the RD11 from the SDSS. Okay, SDSS is the company which is always do some kind of research on that one. Okay, and so they will take the images. Okay, and from that particular images we they are going to be classifying it whether it is a galaxy, a star, or stars. Okay, so that's what the problem statement over here. Okay, so now these are the steps. Actually, the first step is that a classification of galaxy, stars, and about the notebook and about SDSS and important libraries we are going to be importing it. That it could be the first one. Second one is the data acquisition, like query feature descriptions, and we need to go for understanding that data and data explorations, and then feature engineering and machine learning. We are going to be applying the different kind of machine learning models, something like a KNN, Navibase, XGBoost, okay, random forest, support vector missions. Okay, these are the classification algorithms we are going to be applying in the same data set. And from that one we need to go for do some kind of cross validation in the sense you know uh, so we need to be go for validate your model how it is accurate. Okay, with the different training sets. And from that one we need to go for finding the best hyperparameters. Okay, and testing those particular optimal hyperparameters. And then after that one we need to go for evaluation of your model. Then finally we are giving the confusion matrix and precision recall and F1 score. And with the help of this one we are going to be evaluating your model. Okay, so this is the index of this particular thing. Okay, so first we need to go for understanding of what exactly the SDSS. Okay, SDSS in the sense it's a Sloan digital sky survey. Okay, so basically what they will do is a project which offers the public data of the space observations. And observations have is made since 1998 and have been made accessible to everyone who is interested. So who are interested to do this kind of project. Okay, the data is available and we can work on that one. For this purpose, a special 2.5 meter diameter telescope was built at the Apache and Point Observatory in New Mexico, USA. And the telescope uses a camera of 30 CCD chips with a 1048 1040 images point each. The chips are ordered in a row of 5 rows and with 6 chip in the each row. And each row observations the space through different optical filter UGRIZ. These are the optical filter at wavelength of approximately 354, 478, 628, 669, 929 nanometers. Okay, with the help of this one we would like to get some kind of images. That images we are converting into the numerical format that we can do with the help of the deep learning. But we are not worried about a deep learning because of the data which is available with the numerical format only for this particular project. Okay, so the telescope covers around the 1/4 of the Earth sky, therefore focus on the northern part of the sky. Okay, for more information, awesome project for this one, we need to go for visit this particular website, and it will give you a lot of information. If you click on this one, you will be getting that the project and the data, or else the website and the company what exactly it is doing. And so if you have a time, then you can go ahead and look this one and try to be go for understood. Okay, clear? Fine. See, if you want to performing this particular project, we require some kind of Python libraries. So those libraries, something like NumPy, Pandas, Matplotlib, and Seaborn. And these things we can do for data processing or feature engineering part, we will do with help of those things. Okay. And for example, if we have a data set, for that particular data set, I want to make it like a training and testing. And for that one, we can use the model selection. From that one, train test split method will help you to split your data into training part as well as a testing part. And this is the cross val predict will help you the prediction of your cross validation. and that could be the model selection actually. And so you already know some kind of classification techniques, right? Support vector mission, random forest classifier, SDC classifier, and KNN classifier, Gauss Naive Bayes classifier. Okay, and this is the PCA. It's a principal component analysis, and with help of this one we would like to go for okay, and finding the best features actually. Okay, so and so anyway, I was not explained about PC as of now, and Navibase also I was not explained. I can explain you in the further session. This time we are concentrating on the XGBoost classifier because of it's a one of the ensembling technique like random forest. Random forest is the bagging technique, and this is the XGBoost is the boosting technique actually. So we are going to be understanding of XGBoost. And anyway, we just it's a mission learning. As a data scientist, we are not spending much time on building the model actually. Okay, as a data scientist, we are mostly concentrating on the data cleaning, data mining, or data. We should make the data in a proper way. After that one, you just apply the machine learning, and then we are getting some kind of result, and we need to analyze it, and then we can do some kind of operation. That's not a big deal. Okay, but anyway, so if we have some kind of machine learning classification algorithms we're importing over here, and so here label encoder will help you. Label encoder will help you to convert your object data type into the numerical data type. Okay, and here min-max scalar will help you feature scaling. Feature scaling in the sense the data it could be in the same scale. Okay, for that one we can use the either min-max scalar or standard scalar. We can use it. And these are the matrices like confusion matrix, precision score, recall score, and F1 score will help you classification, whatever the classification model we have it, that model, whether it is a good model or a best fit model or not, for that one, we can use this kind of matrices. Okay. In case of regression, we are going to be using the mean square error, root mean square error, R square error, register R square error, AAC, BAC, different kind of things we are using as the matrices, right? In the same way, in a classification also, we are going to be using the confusion matrix, precision score, recall, and F1 score. Okay, that's fine. So this libraries, like if you, it might be sometimes we are going to be getting some kind of warnings, and if you want to ignore those warnings, then we can import this library. Okay, this is what we are going to importing the libraries, important libraries we are importing as a first step. Okay, then a small size it could be the 10, and medium size it was 12, and we are creating that every image with this particular sizes. Okay, clear. Now the part is that it's a data acquisition. Okay, so a data acquisition in the sense we need to gather the data and do some kind of operations on our data, right? For that one, data acquisition is a concept. So let's talk about data acquisition. Okay, so let's go for data acquisition over here. Public data from the SDSS. So you already know that what exactly the full form of SDSS, right? It's one of the company. Okay, and they're doing research on the stars. Okay, can be accessed through the multiple ways. I used that cash jobs website, and website which offers the offer SQL based interface which tell you a query their database which contains the released data. For more information about how to get the data from SDSE, and we can go ahead with this. Okay, we can go ahead with this one. With help of this one we can access the data from this website. Okay, but you don't worry about it. It's having it. Okay, so this website which is providing it, it's Kaggle is having it. Okay, I used the sample query given by the cache jobs to receive the data and find exact query below. Okay, so we can use this query as well. This is the query we just execute on this here. If you're executed, then you will able to data access.
Is that like the SQL query?
Yeah, that's a SQL query. But I'm not did this one, but that's the way we will do it actually. How that guy is did it, that he was trying to explain it. But this is the SQL query
So
he used
SQL
on this.
query, but can be, oh, but we can still do it in Jupyter, or how does it work?
See, actually, you don't need to worry about this one, which is
Uh,
available in the Kaggle. Okay,
oh, I
but
see. Okay.
he was trying to explain that how he got the data from it. Okay, so for example, if you want to use the same project in your resume, okay, we can explain about this website, and you got the data from this particular data access. And you run this query on our cache jobs, so that you got a data. Then we did some kind of operations on that particular data. This way you just explain it. Okay, and yeah, so he was like, trying to explain about each and everything. Okay, so in this particular data, which is the data set which is having the different kind of features. The features we have here, obj, this is nothing but object identifier. Okay, raw in the sense j2 j2000 right escalation r band, deck in the sense j200 decline r band. So this is related images. Okay, what exactly that images, we just go and read this one. Right acceleration abbreviated audio, this is the angular distance measured eastward along with the Celsius equator from the sun at the March. Okay, equi- equinox at the hour circle at the point above in the earth in an equation. So different kind of scientific calculations or equations you have it when paired with the declines, and we don't need to worry about actually, first of all. Okay, so who are having the domain expert in that particular area, okay, they will understood and they can create the data and they can provide you actually. Okay, but you should know what exactly those things. That's the reason we can go ahead and read it. We can understood. And here you better off the dev and x magnitude fit, and better off dev x magnitude fit, and ug or iz, these are the um I think it was explained over here what exactly. This is the optical filters. Okay, these are the optical filters used it, and that what he explained. Run in the sense run number, and rerun number, and cam call camera column, and field number. This kind of features we access the data from this website. These are the features we access from this particular website. And redshift, final redshift, and plate number, and mgd of observations, and fiber id. These are the data we can try to be go for understood. First of all, once the data acquisition is done, then we can do some kind of data you know data exploration. That means we try to be go for understand, is there any kind of null values is there, or else any other things we have it, like we can do some kind of visualization that we can do with help of the data exploration. Okay, the basic stats about our data set. Let's talk about first look our data set, see the looking work on it. So we are just displaying the first 5 records, and this is the obgid, ra, dic, and ug or iz, and run, rerun, cam call, and field, and specogid, and class, redshift, plat, and mgd, and fiber id, right? So this is your target variable. This class is your target variable. Okay, so this is your target variable. Rest of the things we can consider it could be your features variable. Okay, or else your input variables or independent variables. Okay, we can tell that we have all features described above query, and we notice that there is no categorical features at all beside the class column. So except class column, everything it could be numerical data only. Okay, some of the machine learning models can't handle the categorical features, so that make sure that we need to be convert all data it could be into numerical format. So anyway, with help of the info function from the pandas, we can able to get it what kind of data type of each one. Okay, and everything it could be integer type or float type only, except class column. Okay, so the class which is objective because of it's a categorical data. Okay, the dataset has the 1,000 examples, and 17 features column, and from that one it could be the target variable, and 8 of the 17 features are 64-bit integers, and features something is link, okay, and one feature, okay, one feature is an unsigned 64-bit, 8 are 64-bit float target numbers. So he was just trying to explain about each and every data type, okay. So with help of that describe, he is giving that, like, what could be the minimum value of that particular column, what could be the max value, what could be the median value, and what is the mean value, and total number of count we have it. That everything he was trying to be displaying with help of the describe function. Okay, the describe function, which is giving that the mean value of each and everything, and max value as well as mean value of each and every column except categorical. Okay, now, so I just want to know that how many classes I have it. So I have a three classes are there. That it could be the not a multi. This is not a binary classification, which is the multi classification problem. Like the class which is having the galaxy. For the galaxy related observations, we have the approximately 5,000, and stars we have approximately 4,000, and QSO, which we have the 850 records observations only. Okay, so this is the data. 50% are the galaxy, 40% it could be the stars, and 10% it could be QSOs. Okay, but it is not balanced data. So if it is not a balanced data, some situations, if you're getting the good accuracy, okay, it won't, maybe your model is not good. Okay, make sure that when you are working with the classification problems, and it should be a sample balanced data. Okay, but unfortunately this is unbalanced data, because of there could be some kind of majority observations are galaxy, and minority observations are, it could be QSO, right? So there could be a lot of difference we have it in perspective of count. Okay, so it is not a balanced data, but even though, no worry, we are not talking about what how we can work with the balanced data at this moment. But I'm just generally telling that if your data is, it's not a balanced data, if it is imbalanced data, and if your classification problem, if you're getting the accuracy, it could be the 90% or 80% or 95%, 99%, don't depending on that. Okay, even you're getting the high accuracy, it won't give you the better result in a new values. Okay, so that's what so if your balance, if it is not a balanced data, maybe if your observations are, if maybe your model is good, but maybe there could be some kind of issue in our data actually. So make sure that you should make the data as a balanced. For that one, we need to up sampling or down sampling, we have to do it. Okay, but that thing we are not working at this moment. We are just applying different kind of classification problems on our data, and let's see the some kind of results over here. Okay, these are the columns I have it. These are the my columns from that particular data set, and from that one, maybe some of the columns are correlated on which any correlation to the outcome could be coincidentally. So which means that maybe one, it was depending on the another one. Okay, so we are going to be displaying that one record after you removing this features. These are the features are not important for me, like field fiber id or cam call or rerun run object id, and maybe spec gid, spec corb, okay,
So
spec object.
based on correlation, and because these don't have much correlation, we are removing, is it?
Maybe these are the this is the IDs, right? Object ID, okay,
Oh, okay.
fiber ID, and
Okay,
a
got it.
specific
Okay,
object
I see.
ID. Okay, these are the IDs. And coming to this run and rerun, maybe this run and rerun, it may be depending on both. Okay, these are the independent feature, and this is also independent feature. Okay, if any two independent features are correlated to each other, that means it could be multi-collinearity. Okay, that kind of problem, if we have it, we can, instead of using the both, or else you can remove it actually. Okay, that kind of features we don't use it. Okay, so drop those columns if any correlation to the outcome would be a incidentally. Okay, and so these are the columns we are removing, and once if we remove this one, This is my final data set: ra, dec, ugri, z, class, and redshift, plate, mgd, and fiber id. This is fiber id, and this is field. This is field. It's not id, it's a field. Okay, maybe. So anyway, some of the columns we should remove it. Maybe it was correlated mostly on one by another one. Okay, one or another one, so we just need to be remove it. Like the first thing is that univariate analysis in the sense we are taking the one variable and we are observing that what it could be data is talking. Okay, like I have a class is stars, and I have a class is galaxy, and I have a class is qso, and I want to see that redshift, how the redshift respect of the star, and how the redshift respect of the galaxy, and how the redshift respect of the qso, and that we are going to be dist plot in the sense density plot. We are plotting the density plot. See, for the redshift, which is normally distributed, right? Okay, and here the mean value, it could be zero mean, that centered value is the zero. Okay, and coming to the redshift for the galaxy data, here data is normally distributed, and so the mean data it around in between 0.1 actually. But when comes to the qso for the redshift, which is not normally distributed, and so the data which is talking, there could be some kind of outlier. So in c we can see in the in redshift 4 in a 4 part, we have some kind of two outliers. In a fifth also we have some outliers are there. That means the QSO with respect of the redshift, it is not normally distributed, and there could be some kind of outliers, that it was explaining this statement. Okay, we can read it and we can understood what exactly this graph is talking. Okay, whatever I explained, the same thing could be available in a text format. Okay, now meanwhile, this is the lv plot in the sense it's a box plot. It's a simple we can able to display the box plot. Okay, the minimum value which starts with a 0, and it could be in between the 55 actually. Okay, and the same galaxy also, which is in between 0 to 16. Okay, and see, we can see stars tend to the amount of large part consisting the values between the, okay, the largest part data points lay within the 0 to 10. So you just see the line, this is the big line, right? This big lengthy line which in between the 0 to 10 or not. That means what exactly which is talking, actually the largest part of the data points lays between the, okay, 0 to 10, and another large data consisting the values between the 10 to 55. Okay, most of the data, I mean large data, it was between the 0 to 10, and in between 10 to 55 also the data it will be consisting, right? Only small amount of data is lower and higher than this ranges. So more than 55, very less data we have it. In the same way, coming to the galaxy also, large number of data, it was between 0 to 45. Okay, and in between 45 to 60, okay, some range of data we have it, and most of the less data could be available, it's a more than the 60, right? And the same way qso also, which is also between 0 to 52 or 53. Okay, large amount of data can be distributed over here, and somewhat data it could be distributed in between 50 to 60, and very less number of data it can be distributed, it's a more than the 60. Okay, so this is the data which is talking actually. So I hope you can easily understood if you read this text. And now multivariate analysis. Multivariate in the sense, maybe you can go ahead with um, this is the red color correlation. So u versus u will could be very thick red color, right? Okay, so that means q versus q, it could be correlated to high. Okay, this mm, this blue color indicating that less correlation. Okay, less correlation. And red indicating that high correlation. And so this range you can see 0.75, 0.8, 0.85, 0.9, 0.95, 1. Okay, so the medium thick, which it could be 0.75, and less blue color, it could be 0.8, and very less blue color, it could be 0.85, less red color it could be 0.9, and medium red color it could be 0.95, and very thick color it could be the 1. Okay, so that means if based on these colors we are saying that maybe this ZIRGU are depending one by one with the less some of the thing it could be very high. Okay, so that's what a correlation heat map actually. This is the heat map which is talking about correlation only. Okay, so we can see this code which is a correlation of stars UGRIZ and galaxy for the UGRIZ, and for the QSO of UGRIZ filters. Okay, and yeah, so with the help of this graph we are saying that there could be some kind of, we can able to see the correlation of each and everything. Okay, and this is the lamp plot. With the help of the lamp plot we will see that what range of classes we have, stars, galaxy and qs, and in a raw. Okay, so now we have to go for apply the feature engineering UGRIZ. We will know reduce amount of dimension by replacing the different bands UGRIZ by linear combination with only 3 dimension using principal component analysis. So that means this is the principal component analysis will help you to reduce the dimension, but don't worry about this step at this particular moment. I'm not explained about the principal component analysis as of now, but usually this PCA will help you to reduce your dimension. For example, if you have the 10 features, maybe 5 features are good. Those 5 features only we are going to be using it. Okay, so let's see that example. Label encoder, and we are transforming your class also into the number format, and we are applying the PCN components equal to 3, and we are fit and transform of UGRIZ, and then you're getting the URG. This is the one model. This is one model, and then what I'm doing here, you're updating your data frame, and we are going to be creating this SDSS df underscore fe, and we are concatenating the your SDSS underscore df underscore fe. This is the data set, is your original data set, and we are adding for your original data set this result actually. Okay, this result, whatever the transformation, whatever the result we are getting, that we are adding over here, and you're concatenating this your original data frame and your result of this PCA, and we are concatenating each other, and we are renaming that. There could be 3 components, right? So here we have a 3 and 0. It could be the PCA underscore 1. For 1 we are updating like PCA underscore 2. For 2 we are updating like PCA underscore 3. Okay, and we are dropping that UGRIZ. So instead of taking this 5 features, we are taking only 1 feature. Okay, instead of taking this 5 dimensions, we are taking only 3 dimensions when you are giving the n value is the 3. So we are just replacing UGRIZ by the PC underscore 1, PC underscore 2, PC underscore 3. So previously we have the 5 columns, right? Now we are having the 3 columns only. This is the way you're generating the new dimensional or new data set. So this is the data set I would like to go for using the my machine learning model. So as of now, you're not understood the importance of PCA, that I can explain in upcoming sessions. Now we would like to go for applying the machine learning like feature scaling. Feature scaling, it can help you to convert entire data. It could be in a same scale. Then with the help of the train split method, we are converting your data set into 67. Yes, 67 data, it could be the training size, and 33% it could be the test size. With the help of that data, we are applying the KNN classifier, and we are getting the some kind of time consuming for the training and time consuming for the prediction. This is the time also we are considering over here. Okay, and the prediction accuracy, it could be the 92 percentage. And Navibase I was not explained, I can explain you, but even though you can run the code, and you will be getting the 97% of the Navibase prediction accuracy and the time consumption for those thing. And XGBoost, it's one of the boosting technique. If you are taking the n estimators, that means you are taking the 100 models, Okay, and
The time
estimators.
time consuming is nothing but the execution time, is it?
Yes, execution time.
Okay.
So to train execution time, model training execution time. Okay. Say for XGBoost, it will take a lot of time. See, 1 minute, approximately 1 minute. The reason is that it was taking the 100 base, okay, class 100 base machine learning algorithms, and we are training those algorithms sequentially. So this is the sequential model. Okay, this is the sequential model. This is not like Navi base, or else this is not like KNN. This is a single model. But when it comes to the XGBoost, it could be the, I already explained about XGBoost. XGBoost, it's a sequential model actually. One model, if you are getting some kind of wrong prediction, then we are adding some kind of weights and the input we are giving to the next model. This is the way we are taking the 100 models, 100 base models, something like this. 100 base model, it could be sequentially connected, so that it will be take a lot of time for building the model, and it approximately 1 minute, and the accuracy, it could be the 99.442. Coming to the random forest, it's a parallel execution, so that it will be less time. So here also we are taking the n estimators at 10. Maybe you can take the 100 also, but this is the parallel processing. This is the sequential processing, so that it will be take somewhat time. But random forest, it was giving the 99.15, and this is 99.47. So when you compare the prediction accuracy, XGBoost is a good for this particular, okay, project. And meanwhile, we are going to applying the support vector mission. For the support vector mission, the prediction accuracy, it was 89.27, and timing training execution also, it could be very high. And we are seeing that which score is good. So XGBoost score is good when comparing to the other algorithms, right? So that I would like to go for applying the k-fold cross validation, and for the random forest, and for the average, it could be the 99.17. For the XGBoost also, I can able to go for cross validation. So cross validation in the sense, we are saying that what could be the your model. Okay, so we are validating your you're taking some kind of better things, a better model. We are generating the better model. So here we are taking the 10 samples, or 10 times we are running the same model with a different with the same training data. So approximately 99.31 percentage, it could be the good. So that I'm finalizing that XGBoost is my good accuracy. So I would like to, meanwhile, I would like to go for finding the important features. So if I want to know the what could be the important features, we have the coefficient, or um, attribute feature underscore importance for this particular XGB classifier, then automatically which is giving that percentage of each and everything. Okay, redshift 37%, PCA 17%, PC2 11%, fiber ID 0.8%, and PCA1 8%, RA 5%, DEC 4%, this is 3%, this is 2%. This is the way each and every feature importance on our class. Okay, so that we can able to look for it, and this are the features importance only we are going to be displaying on bar chart, so that from this all, redshift is more important, which is very very important for the classification of galaxy or star or QS. Okay, and we just need to go for a min max scalar, and we are just applying that entire data. It could be same square, and then and we are just displaying the data. And finally, we would like to go for hyperparameters, finding the best hyperparameters, and max depth, it could be the fine. Okay, so if you see this one, if you see this one, so this, it will give you the best depth everything. So this is the XGB which is giving that not only score, and meanwhile, what could be the width in the sense, like, okay, max depth and Milchide weight, gamma values, these are the best parameters found that tuning the best test are. And and we are just taking the data again, test data and train data again. We are running with new test values, and we are finalize. This is the percentage, 99.93 percentage with the prediction accuracy with the test data. Okay, and now we are applying cross validation. For the cross validation, 99.26. And so evolution, for evolution we can go ahead with the confusion matrix. There could be three classes, right? So these are the three classes. These are the confusion matrix. From the confusion matrix we find the precision and recall score. Precision is 99 and recall also same, so that if it is the precision and recall, if both are same, then my f1 score also it could be the same because of its harmonic mean, so which is approximately equal to 900, right? Even f1 score, recall, and precision, everything it could be high. So that finally what I'm trying to tell you, for this particular model XGBoost is giving the best result. Okay, so that's what this is the way any machine learning algorithm, or we can work with any project actually. Okay, clear? Any questions?
I think this is a lot to digest and probably practice or
Yeah,
try it again.
yes, of course, it's very
Yeah.
important. Guys, I'm sending you in a chat, Zoom chat, this link. Just click on it and try to be go for understand it. Okay, lot of
Mm.
information could be available. Kaggle is
No,
giving the best.
we do not have a Zoom chat here. Yeah.
Mhm. Okay,
The
I can
option is
upload it.
removed, I think. Yeah.
Okay. Mm, to upload it.
I don't have Kaggle. I'm sorry.
You
Oh,
can
you
create
mean
it.
to upload it to Canvas?
Yes, I'm uploading
You
into
upload it? Okay.
Canvas. What we can do, if you don't have the Kaggle, create your, just if you have a Gmail account, you can create it. Akash, Kaggle is very, very important. If you want to become like a data scientist, definitely Kaggle is the best platform for you. Okay.
You. Excuse me, there are some lectures you haven't uploaded for me because it's not showing on Canvas. Upload all the lectures.
Okay, I uploaded only 5 lectures as of now. I would like to try to upload rest of things, whatever I have it. But so if nothing, if it is not available, that means maybe sometime I couldn't make the recording actually. Okay.
But
Yeah.
if it's
Yeah.
upload,
So anyway, I uploaded that, the link for the XGBoost. We can go ahead and look at that particular project, and hopefully you will get it.
thank you.
Yep. Bye. Take care.
And if we can just upload some of the lectures too, if we
Sure.
have the
Sure.
recording.
Sure.
Thank you.
Sure. Whatever the recordings I have it, I would like to try to upload it.
Anjan, we are not part of this class. We were
Yes, sir.
using something.
Okay. Okay. Fine. Sorry.
ADS 303.
Yep.
Oh, there were no recordings of ML also. Yeah.
Okay. Mhm. Okay. XGBoost. Okay. Go ahead, guys.
Yeah.
Enjoy the project. Take care.
Thank you.
Thank you.